In this video, I'm going to do one example of implicit differentiation. It is going to have a trig function in there, so we are going to have to refer to some trig identities and some reciprocal identities so that we can do some substitutions in order to simplify our answer down to the most simplified answer that we can get. It was a cotangent of y right here, so I've done all of these formulas in terms of y as opposed to in terms of x, just so it kind of matches up with the problem a little bit better here. This is your standard Pythagorean identity right here, and all I've done for here and here is just rearranged this, solved it for something else. I solved this first one here for cotangent squared y. Alright, just subtracted 1 from both sides. Then I took this one and multiplied through by a negative just to see that these are all equivalent. Just a little bit of algebra manipulation to get what you're going to need in this problem. Pretty common reciprocal identities, the 1 over cotangent squared y, and then that's going to be negative, or that's going to be tangent squared y, and you can have negatives on both sides. It's not going to affect that formula. So again, set this up so that it will match what I need to do for this particular problem. Alright, now usually when I start an implicit differentiation problem, then I indicate to the person that's looking at the work that, hey, I'm taking the derivative of both sides. So I set it up with a ddx on both sides of the equation. So ddx of cotangent y is equal to, also taking the derivative of the right hand side of the equation, so ddx of that x minus y. Alright, now I am assuming that at this point you've got all your derivatives memorized, so the derivative right here of the cotangent y is going to be a negative cosecant squared y, and since we are doing implicit differentiation and this is a y term, then I'm also going to have y prime in there. Alright, a lot of people will use dy over dx. It's the exact same thing as y prime. It means first derivative. I think that y prime is a little more cleaner in the problem. Okay, over here I'm going to take the derivative of that x, which is just going to give me a 1. Derivative of the y is also going to give me a 1, but because it's a y term, I will have the y prime in there. Okay, now at this point, I do need to have my y primes all on the same side of the equation because ultimately I'm going to solve for y prime. So I'm going to add y prime to both sides of the equation. So I'm going to have a y prime is minus the cosecant squared y prime, and then is equal to 1. Now I've set this up so that I can factor out my y prime. So we factor out that y prime, I'm going to have a 1 minus cosecant squared y is equal to y. I'm trying to solve for y prime. Going ahead and solving for this, I'm going to have a y prime is equal to 1 over 1 minus cosecant squared y. Now, technically, you are technically done at that point. However, alright, it is trig. There's some trig functions in here. So, if you can see and recognize what you can do substitutions for, we can make this answer a lot cleaner. Alright, I've got a 1 minus cosecant squared y. 1 minus cosecant squared y I can replace with a negative cotangent squared y. Alright, this comes from that original Pythagorean identity with just some algebra manipulation. So I can do a substitution there, and I can have a y prime is equal to a 1 over a negative cotangent squared y. Alright, and then again, recognizing this as one of the reciprocal identities, I can replace it with a negative tangent squared y. So all that last part does is just clean up the answer. Alright, this clearly is a nicer answer than what we had up here. Alright, not that you're wrong at this point, but you can just keep simplifying and keep simplifying, and it makes things a lot nicer. Alright, to be able to do all of that though, you've got to have those a really good grasp of those trig identities and then what they kind of look like when you start to algebraically manipulate them. Definitely thanks for watching. If the videos are helping, please share with your friends so that they can benefit too. And don't forget to subscribe to the channel. Thanks.